So how exactly does a smartwatch work? I'm going to be keeping this video pretty short and non-technical, so if you have any specific questions, feel free to drop them in the comments below. I'll be answering questions from last time at the end of this video. So the watch is comprised of 4 major pieces: this controller, the power delivery system, the screen, and the sensors/actuators. The controller is basically the brains of the system. It's responsible for 3 tasks. It writes to the screen, it takes data from the sensors, and it also communicates to my phone over Bluetooth. I'm using a microcontroller for this design, specifically an STM32. Compared to something you'd find in like an Apple Watch, it's a bit of a potato, but it's a lot easier to write software for. Next, we have the power delivery system. It starts with the battery, which passes through some protection circuitry, and then through some voltage regulation modules. Lithium batteries are really dangerous if misused, so the protection circuitry just makes sure something doesn't blow up. In the same vein, the voltage regulation modules just make sure components receive the right voltages, so nothing blows up. And the last piece is the wireless charger. So there's going to be a coil on the watch, which corresponds to a coil in the charging pad, which allows for wireless charging. Moving on to the screen, I'm using this circular LCD I bought off eBay for pretty cheap. I eventually plan to upgrade to an OLED display. LCD screens rely on something called an LED backlight, which lights up the entire screen. This light results in a dark gray if you try to display it black. On the other hand, OLED screens light up each pixel individually, so you get a much deeper blacks. And if you only want to light up a few pixels, it takes up way less power. This would allow for something like an always-on display, but they're a lot more expensive too, so I'm just going to be sticking with the cheap LCD screen for now. Finally, we have sensors and actuators. There's a whole slew of different things we could use, from speakers to microphones to a motor for notifications. Really, the only limitation is how much stuff I can cram inside the watch. To keep things simple, I only have 2 sensors, this accelerometer and this all-in-one sensor that does heart rate monitoring, blood oxygen sensing, and does ECGs as well. That's about it for the technical rundown, so I want to answer a couple questions that you guys had. One of the clips in my last video, I showed off some boards I made, and people asked how I was going to fit all that inside of a smartwatch. So the boards in those videos were only test boards. They're actually pretty similar to something like an Arduino, where they have one chip that does 90% of the work and then a whole bunch of extra space for connectors and stuff. So when I go ahead and make the final logic board, I'm just going to strip away 90% of these connectors and just connect things directly to one another. If I do need a connector, say for example from the battery to the logic board, I'll just use something like one of those Lego connectors that you find in most modern smartphones. And I made these test boards first just because I find them a lot easier to work with and a lot easier to debug and correct things if I made a mistake. It does take a lot more time and it is a lot more expensive, but I feel like it's worth it based on the amount of time I'll save debugging later down the road. I got these boards from a company called JLC PCB, but there's another company called Oshpark that I want to try out with my next order. For the watch enclosure, I plan on using 3D printing. I do have some rough sketches in CADs, but nothing set in stone yet. I eventually want to machine the whole thing out of aluminum, but that comes with its own set of problems. The last group of questions I get a lot is about the design process in general. Whether that's how do I take my idea and convert it to reality, or how do I take this massive breakout boards and convert it to a single PCB, or how do I troubleshoot when something goes wrong. And to be honest, I'm not the most experienced person when it comes to this, but I would like to make videos in the future that cover some of these topics. In the meantime, I dropped some links in the description below to some of my favorite engineering channels that cover some of these topics. Hopefully I answered all your questions. If something was unclear, or if you just like more info, feel free to leave a comment. Next time I'll be covering how I managed to burn my desk, amongst a bunch of other updates and other cool stuff. So stay tuned for that.